Well, howdy everyone, and thanks for being here as part of this session for Discover. It's a delight to have you. And as we get started, I just want to remind everyone, nothing that I say can be taken as a forward-looking statement. We're sharing a perspective on a constantly evolving topic. So what we're trying to do is give you some insights from our work with customers over the years and what we predict is going to happen in the future. But again, it's our best guess at this point. The other thing we like to say in all of our sessions is we value your feedback. So if you think we got something right, let us know. If you think we missed the mark on something that we've suggested, let us know that too. We constantly want to get better. Our desire today is to share with y'all what we think we've learned over time, helping customers both in IT efficiency and in AI sustainability to accelerate your progress forward. Now, AI is a great set of solutions. It has great opportunity, but it also comes with many challenges. And so we have increases in the amount of data that we've got to collect to train models, for example. The models sometimes are getting bigger, and then all of a sudden in the last 6 months or so, some of them are actually getting smaller. And so how do we make those decisions? New algorithms are coming up. Things like agentic AI are all of a sudden top of mind, and we're talking about that. So lots of opportunities. At the same time, though, these systems and these solutions take a tremendous amount of infrastructure. They consume a lot of energy at the same time. So often we have this dynamic that we need to start balancing for as well around sustainability and efficiency. But with those challenges, you might wonder, well, why don't we see more AI solutions at scale? And there's a variety of reasons for this. This was pretty shocking to me that as we talk to customers and as these media outlets have interviewed customers, what they find is many of them started down this AI journey and didn't even have an AI strategy. And as you can see from the fact that only about 10% of these pilots actually go to production, that these challenges were insurmountable for the customer that was working on that. And by the way, these numbers match the numbers that we hear from customers when we're having conversations with those customers over time. So how do we prevent this problem, or how do we allow more of these pilots to actually go to production? Some critical things in there. Consider AI ethics as part of your development. Consider efficiency as part of that development. Have an AI implementation strategy. Manage the regulatory implications as well. There's a variety of things that need to happen to make these solutions successful. But at the same time, we're also seeing changes in our infrastructure requirements. All of a sudden, we're seeing increased power density, where the average rack density for enterprise workloads is about 4 to 6 kilowatts per rack. With some of these AI solutions, we can see power densities over 100 kilowatts a rack. And we have many racks, perhaps, particularly if you're doing training. Much of our processing experience is in parallel processing. Many of these training workloads are actually batch processing. And how is that vastly different, both from an infrastructure perspective, but from a scheduling perspective of those workloads as well? Often we are reaching the points where we have to go to liquid cooling, and usually direct liquid cooling. And in fact, if you look at processor roadmaps over the next couple iterations, we're going to quickly reach a point that the processor manufacturers not only recommend, but they require direct liquid cooling to handle the heat output. And at the same time, by the way, in case you have not seen this phenomena, where it used to be that each new generation of gear had about the same power envelope as the previous version and the same thermal envelope that it could operate in, what we're seeing now is the critical temperature of these new processors is actually dropping. So they give off a lot more heat, and we actually need to keep them colder than we used to have to keep existing infrastructure. So you have these two dynamics coming together in the middle, and that's forcing some very different resource conversations. And finally, more and more we're being asked to measure the power consumption, and I think we're going to see that regulated in more places around the world as well, as this common thought of AI consumes a tremendous amount of energy. companies want to stand up more AI workloads, and we're seeing the utilities actually push back, and even regulators push back and say, if you don't drive efficiency from the start, we're going to regulate your use of some of these technologies as well. So we've got to keep all of these challenges in mind, and they're coming at us together. Let me give you just one example that I alluded to earlier. Model designs historically grew like this. More and more tokens, getting large, bigger models. They took longer to train, took lots more resources. It's almost as if the model developers said, assume we have unlimited power availability and assume we have unlimited hardware, and let's build a model and see how big we can get it. The accuracy got better, didn't get great in some cases, it got better, but the resource demand was tremendous. And everybody said, and common thought said, this is the way it has to be done for accuracy. And then something happened a couple months ago. This company that most of us had never heard of before called DeepSeek came in and said, no, actually we can get accuracy way down here. Much smaller models, much fewer resources, limited power budget. And then everybody thought, well, wait a minute, maybe they're not disclosing something, maybe it's not really what it was claimed to be. And then some of the other big model developers followed the trend. So we even have this challenge right now, large language model, small language model. Does one give you better accuracy, or can you take other techniques that drive the efficiency of that AI solution? We expect this to continue, by the way. We don't know that one solution or one size fits all, and you can actually get really nice accuracy with small language models and techniques like RAG, or retrieval augmented generation, to give you some of the technical expertise you need, particularly if you're building models for technical disciplines where things are well known, like law, medicine, and other things like that. Lots of ability to be very accurate with much smaller models. So how do we start thinking, if we're going to have to implement an AI efficiency strategy, how do we start thinking about going about that? And one of the things that the practice I lead for HPE has been doing over the last 25 years is working with customers to drive efficiency in their enterprise broadly. And what we think we've learned is that there's 5 key levers of sustainable transformation, and I'll give you a little taste of each of them as we go, but know that we have some free resources that I'll share with you at the end, so you don't have to take frantic notes here if you don't want to. And the first of those is equipment efficiency. If you have a piece of technology equipment, have it do the most amount of work possible. Now, that seems intuitive, but when we look at industry statistics conducted by groups like the Uptime Institute, we find that most of us use our technology infrastructure, the hardware devices, at very low levels of utilization. For compute, it's often 30% for virtualized workloads and even less for a single application on a piece of hardware. Storage, often 40% utilization. So we have our infrastructure way over provisioned. We're using our equipment at low levels of efficiency. Now, some of you might say, but John, it wasn't designed for efficiency in the first place. It was designed for resiliency and redundancy, and that's true. But we've got to consider efficiency in there as well. The second topic then is energy efficiency. If we're going to consume a kilowatt of energy, let's do the most amount of work possible for that kilowatt of energy. And so that starts thinking about, what's my tech refresh cycle? I have older equipment in my infrastructure that consumes a tremendous amount of energy and does a little bit of work. In fact, Uptime found in a 2020 survey that they surveyed over 600 data center operators across the world. And those data center operators reported that over 40% of their total infrastructure of compute was over 5 years old. It did 7% of the work in their data center, but consumed 66% of the power in the data center. That's not a great return on investment. That is a tech refresh being needed quickly. The third then is resource efficiency. Beyond the equipment, beyond the energy powering the equipment, how many people does it take to run it? How much cooling does it take? How many power conversions occur from the data center wall to the time we actually power the equipment? And for about 10 or 15 years, this is how we worked with customers. And then we realized, well, wait a minute, nobody's talking about the applications. Some of them are designed very inefficiently. And yet, academics would suggest that about 50% of the efficiency opportunity lies in the applications. So how do we do a better job writing better applications, coding better applications, even using programming languages that are more efficient, like Rust and C? And finally, data efficiency. And as we start thinking about AI efficiency, if we train models with data sets that are full of garbage, we should not be surprised when we get poor accuracy output at the end. And in fact, there's many examples where cleaning those data sets first pay off in a big way, but also in terms of our users. Almost every customer that comes into our briefing centers to buy storage, we ask them a question: how much data do your users collect and want to store? A lot. How long do they want to keep it? Oh, they tell us they have to keep everything forever. And then industry statistics suggest that the average company only uses about 1/3 of the data that they ever collect. So part of our work with customers is to suggest, how about let's put a data efficiency strategy in place at the beginning, so when a user says, I need to stand up a terabyte of storage, why? What are you collecting? How frequently are you collecting it? How long do you need to keep it? And if you have to keep it forever for regulatory reasons or financial reasons, when can we pull it down to tape so that we're not actively consuming energy for something that we may once every 10 years have to go recover? So those are our 5 levers. And as we started thinking about how these applied to AI efficiency a couple of years ago, we realized they all apply. And we call them levers because the impact of any one of them may vary depending on the workload and depending if your workloads are in the public cloud, in a hybrid cloud, in a private cloud, or even on the edge, but they all still apply. You can stand up very inefficient infrastructure in a public cloud actually easier than in some of your own infrastructures. So we've got to consider them all. But for AI then, we want you to think about the life cycle of AI when you start thinking about efficiency. So if we look here at the average AI life cycle, some of you may be really on this front end. You're actually building solutions from the very beginning. Define what you're trying to do with the solution. Define who the users are. In fact, one of the things that we say around the next element, the data piece of this, is if you don't gather your data sets with the user community in mind, you're going to miss a lot of things, because the users will tell you, well, I need an AI solution for this, and here are the technical resources that you need to tap into to give me the answers to that, for example. Or if you're building digital twins, go talk to people that have built digital twins, and what data did they find helpful in here. Training requires a lot of these levers we talked about. How many of y'all are actually training big models? Anybody? So my guess, and what we typically see, is very few customers are actually doing the model development from scratch and training the core models. Much more likely, you're tuning and doing the inference on a model built and trained by somebody else. But even in the tune phase, data efficiency is so critical, particularly if you're considering solutions like RAG or some other solution to bring your efficiency down. Inference uses a variety of these levers, and this is something, again, that is changing constantly. And often we forget, let me go back to the last one, often we forget the monitoring phase. So once you go all the way through this life cycle, you're not done. It just loops around again and again. And the solutions are learning. With Agentic, that's part of the opportunity of Agentic. It can be self-learning over time and self-error correcting as we get better. So from an AI perspective then, that's really how we recommend you start down the efficiency conversation. Learning from others, don't start from scratch. Part of the reason we have written the white papers we've written is as we help customers, they said, this is great. Has anybody written this down? And the answer was no. You couldn't buy books on the topic. It's still, in many cases, not taught in university curriculums. So we started writing the white papers. And one of the things that we ask, by the way, if you're leveraging any of our resources, they're all free. We don't even ask for your email address, but we want your feedback because we update them every 2 years because this conversation is rapidly changing and evolving, and we want to make them useful to you. So now we've implemented the 5 levers. Are we done? No. Yeah, we got to laugh up here. We've got to consider other impacts. And if you're designing efficiency in from the beginning, that's the time to consider these other impacts. One that you're hearing more about, Antonio alluded to it yesterday morning in his keynote, is heat reuse. For years, the number one waste product from our IT infrastructures was heat. We tried to cool the devices down, but what do we do with the heat? We just rejected it to outside in most cases. Well, actually, you know what? You can sell that heat. And the higher you can get the temperature of that heat, the more the value of that heat. So if you're thinking about new infrastructures, you're thinking about building data centers or adding white space yourself, one of the questions to ask yourself is there a beneficial use for this heat? And can I do heat recovery and sell that heat? Now, I will tell you, the Danfoss HPE stand here at the show, you can learn a lot more about the mechanics of that heat recovery, but generally speaking, you need a beneficial user of that heat within about 10 kilometers from the heat generation. And again, there's various steps in heat use that as the quality of the heat goes up, in other words, the temperature goes up, the revenue value increases as well. So there's great things we can do from an IT perspective. If the customer says, can you get me 2 more degrees? Sure, we'll run more workloads on a couple fewer devices, generate more heat, pull it off with our direct liquid cooling, and generate a better heat output. So we can even, by changing and shifting workloads, make the quality of that heat better. Renewable energy. Lots of folks are talking about it. Many customers have said, we're already at 100% renewable energy. But that's an annual average. You may have full weeks or months that you're on 0 renewable energy to offset that. So we really want you to start thinking about 24/7 renewable energy. How do we get access to generated renewable power that's very consistent? And you might be thinking about that saying, well, how do you do 24/7 with solar or wind? It actually takes a portfolio of renewable sources to get to 24/7. And finally, lifecycle services. When you're done with those assets, what do you do with them to make sure that your cybersecurity protocols and your asset disposition protocols are handled? And in case you're unaware, HPE has the largest asset recovery network in the globe in our HPE Financial Services. Again, Antonio alluded to it a little bit yesterday, and there's some great sessions on it. But for those assets that are coming back, often they have value, and we share that revenue or that value with you as we're taking back those assets as well. So I mentioned them a couple of times. These are some of the resources we have. We actually have white papers on each of those levers. Some of you came back to us and said, John, that's great, but our executives don't read white papers. Do you have something more simple that maybe has more pictures and some fill in the blanks that we could use to get started on this journey? And so the document on the left, the 6 steps for implementing a sustainable IT strategy, literally walks you through in 6 steps. How do you get started on this journey? Particularly for enterprise infrastructure that already exists. So you're trying to make something that's already in place more efficient. You'll see that coming soon on our AI sustainability white paper. It's in final review right now. And hopefully what you'll get from that white paper and from what we've talked about this morning is, for our AI solutions, let's design them with efficiency in mind at the beginning so that we're not trying to solve for efficiency late in the game. So, what am I going to leave you with here? First off, that QR code will take you to our white papers if you want to snap that as you go. Don't reinvent the wheel. Start from the expertise that we already have and keep moving. Leverage what your peers are doing as well. Often by talking to someone else that's walked down the journey, they can help identify the unintended consequences or the missteps and share it with you. Often we've heard back from many of you that your executive team says, that sounds good. It sounds like it's going to save me some money. It sounds like it's going to help with staffing. But who else has done it first? No executive wants to be the first one to walk out and have the unintended consequences. So let's learn from one another. Implement your strategy and don't forget your AI solutions, even if they're not in place in your infrastructure yet. Drive the efficiencies across your whole environment and measure all your life cycle impacts. And with that, I'm going to say thank you so much for being here today. Leverage those free resources, and we hope we can help you drive efficiencies in the future. Thank you.